So in this scenario, we'll be taking a look at IPv4 numbered extended ACLs. It uses the same scenario layout as for the standard IPv4 ACLs. The only configuration already done on this thing is basically the entire network works. I say only, it's just nothing fancy. So in other words, routing works, etc., but no extra services have been configured. So you can't, so there's no NAT, there's no DHCP, etc. It's simply we can ping from one end of the other to the other, and we can access things on the server. So what do I mean with accessing things on the server? Okay, so on this server, HTTP is active, DNS is active. So the idea behind this server is you can do file downloads from it, but it also hosts a website. Basically, it's just a welcome to the staff portal website. So in other words, you'll see it's on the HR network. And the idea is that people gain access through the HR portal. So in other words, if they want to know things about HR and their role in the organization. Let's see again, services. We also have FTP is active. So we should be able to test file downloads. And then what else do we have? I think that's it. We did see DNS is also active. So we should be able to access that server via HR portal. Okay, so let's do a test. Let's see what works. So let's firstly just see if we can ping the devices over there, 192.168.20.2. Okay, great. So we can access the PC. And then let's see if we can access the server. Okay, fantastic. This device, you will see ipconfig. It has been configured that it uses that server over there as our DNS server. So what that will allow us to do is I can access the website using 192.168.20.3. Or I can access the website using 192.168. I can use it access HR portal, and you can see it actually does the same thing. So we can access it via two ways. Let's just test again that it wasn't just cached. There you can see it works using the HR portal domain name. Okay, and then lastly, we can also test whether FTP works. So let's say FTP 192.168.20.3. The username at a default is Cisco, password is Cisco. And it says, okay, we're logged in. Let's do a directory. And let's try and download something. What's a short file name? That top one seems to work. ASA 842k8.bin. Okay, so we have a file transfer in progress. So in other words, this is actually working. So while it's downloading the file, let's just decide sort of, I mean, this is not scripted, so let's just make sort of a decision what we're going to do. If we're able to do it, great. If we get stuck, it's not intentional. So let's say we're going to go from this network, and what we want to do is we want to allow normal traffic to go to this network. So in other words, these guys should be able to ping, etc., to this side. Okay. We want to allow, let's think about this. No, let's do this. Let's say people on this network are allowed to access the web server to view the web page, but they're not allowed to download anything. So they're not allowed to use FTP on this device. Okay, so let's say we're going to do that. What else? Let's say then they are allowed to access anything else over here on this network, but they are not permitted to ping anyone on this network. Okay, I hope I remember all of that. But let's see if we can do this, if this file transfer will just complete. Sure. Packet Tracer is really realistic on how long it takes with these file transfers. Imagine if I chose one of these larger file types. Okay, but at least we see it's working. I'm just going to leave this here. Hopefully it will continue. So let's go to branch, or should we go to edge? Now here's the question. Standard ACLs are placed closest to the destination, but extended ACLs can be placed closest to the source because we know both the source and the destination of the traffic. So by doing that, we can block traffic from going to specific destinations. So in other words, we can already block traffic over here on the edge device before it traverses across all of these steps of the network. So the closest possible place we can put our extended ACL would be on the edge router going into the device. In that way, it will filter traffic even before a routing decision has been made. So it will save on bandwidth, and it will actually save on processing time on this device, since no routing decision has to be made if the traffic is already dropped as it moves into the interface. Okay, so let's see what we can configure. Okay, so let's take a look at how we'd configure this. So we're going to go with an extended ACL, so access list 101. And what we want to do is, let's say we want to deny FTP traffic from the 10.0 network. So 192.1, and that's TCP traffic basically, because FTP runs over TCP. So let's say deny 192.168.10.0 dot anything, and we want to deny it to the host 192.168.20.3 20.3 when the traffic is equal to FTP. So we can choose to use the keyword, and that aligns with port 21. But technically, FTP uses two ports, one for FTP data and one for FTP. So we have to block on port 20 and port 21. Okay, then let's say we want to permit TCP to 192.168 or from 192.168.10.0 going to host 192.168.20.3 equals either 80 or www. So in other words, 10.0 is able to access the host that is on IP address 20.3 for web traffic. Yeah, spelling mistake. Sorry. Okay, so let's then say we want to deny everyone else, anyone else, it doesn't matter who it is. So access list 101, deny TCP from anyone else going to host 192.168.20.0, 20.3 equals www. So in other words, if you're not on the 10.0 network, tough luck, you are not going to be able to access web traffic or the web server on 20.3. Okay, so what else can we do? We can also then lastly just say something like access list 101 deny, or let's say permit, and we want to permit traffic from anywhere, or let's just say from the host at 192.168.20.10.2 to the host at 192.168.20.2. Okay, just want to say permit IP from the host. Okay, so what IP does is it's basically going to cover us for TCP, UDP, for basically anything that is IP related traffic. So we're going to permit IP from the host 192.168.10.2 to the host 192.168, let's say 30.2, because we want it to be for the admin PC. And now what you have to remember, everything else is going to be denied, because at the end of this access list, there's an implicit deny any. So literally anything else that is not permitted explicitly on this access control list is going to be denied. Okay. Alternatively, I mean, you could also say permit any. So in that case, you would basically have an access list which contains a whole bunch of deny statements, and then lastly just permit anything else. Now in this case, because it's simply an example to show you how we generate these access list statements, it's not a predetermined decision what we want to filter on, etc. So if it's not the most effective one, it's not the point of the exercise. It's simply to show you how to do this configuration, how to actually create the access list statements and how they combine to form a single one. So let's do a show run, and there you can see there's our entire access list. Okay, so let's go and do this. It still works. But what did we configure? We are permitting the traffic from this specific network to access the web server. So it should still work. Okay, so that's not the problem. What shouldn't work is our TCP. So in other words, for specifically for FTP. So ports 20 and 21. So let's see if that still works. That should be broken. So let's try FTP 192.168.20.3. Oh, and what do we see now? We see trying to connect. So as you can see, it's not allowing us to do this because we've broken that connection. We've said that it's not allowed to complete that FTP connection. So let's just try one more thing. Again, this is completely unscripted. I just want to show you something. So let's go access list 101, and we want to go deny TCP from the 192.168.10.0 network going to host 192.168.20.3 equals 53. If I can just do it at the right place, it would be nice. So let's just say set. I'm just going to issue the command again. What did I do now? 0.0.0.255. Okay. And then I'm also going to issue the same statement for UDP. So I'm blocking UDP and TCP ports 53 from the 10.0 network to the host 20.3. Okay, so let's see what that does. Okay, let's wait for it. Doesn't seem to be working, does it? But does that mean our web server is down? Let's test. Remember, we can also access a web server using the IP address. That still works. So why didn't it work when we went for HR portal? Just clear it. Why doesn't that work? Okay, very simple. Even though, let's do a do show run. If we take a look at our access control list over here, even though we are letting through any web traffic going to the host, we are specifically denying TCP and UDP ports 53. Now, ports 53 are for DNS. So HR portal couldn't resolve to an IP address. And that's why we weren't able to use the actual domain name to access the web page. But there's nothing barring us from using the direct IP access. So using the IP address to access. So when setting your access control lists, just remember that defining these things have consequences. That's why, especially when using numbered access lists, it's always wise to do them separately using something like Notepad, because you can actually have unintended consequences. In this case, what we've done is actually kind of silly. Why would you permit the people to have web traffic access, but then you block their DNS access? So then what was the point of setting it up so that they can access the web server using a domain name? So one of the main things to working with access lists is to actually plan it, to configure it in a way that it's not going to break anything else while actually performing the filtering that you want it to filter.